Hey guys, obviously I'm not here today, so I'm going to go through the handout with you in video form. I will pass you out a printed copy of this handout next day, but if you'd like to load it onto your computers, it is on Haiku now. So today we're going to be looking at angles in the plane, so angles, representing angles in the XY coordinate system, and we're going to look at cast rule, which is taking trig ratios of angles that are bigger than 90 degrees. So we're going to talk about angles in standard position. That's most angles we deal with this year. We refer to them in standard position, which all that means is that one of the arms of your angle is aligned with the positive x-axis. So on the diagram in the handout, you can see one side is called the initial side. That's what we call the arm of the angle that we align with the positive x-axis. This is called the initial side or the initial arm. And then from the initial side, we rotate around. And then once we stop, that second arm is called the terminal side or the terminal arm. Terminal side or terminal arm. If I give you an angle in standard position and it's positive, it means we rotate, which direction is positive? Counterclockwise. We rotate counterclockwise from the initial arm. So this would be a positive angle. So counterclockwise. And if we give a negative angle, well, all that means is we rotate clockwise from the initial arm. So this would be the same angle as the positive example if it were just made negative. So this is a negative angle. We rotated clockwise. Okay, so let's look at some quick examples here. This question is asking you to sketch these angles in a standard position. So the first example is 135 degrees. So I'm going to sketch this angle. I don't need that Y. So 135 degrees, my initial arm is on the positive x-axis. I rotate 90 degrees through the first quadrant, so it's somewhere between the first and second quadrant because I've gone more than 90 degrees but less than 180 degrees. In fact, 135 is halfway between the two quadrants, the two borders between the second and third quadrant. But really, all I'm looking for is that your angle is in the correct quadrant. I will label this 135 degrees. Okay, part B, 300 degrees. Where is that? Well, I start in positive x-axis. I rotate 90, 180, past 270 into the fourth quadrant. That's going to give me an angle of 300 degrees. C is negative 240. So this is like the other ones, except it's a negative angle. So starting from the positive x-axis, I this time rotate clockwise. Negative 90, negative 180, not quite till negative 270. So that's going to end up here in quadrant 2. This is negative 240 degrees. And lastly, negative 150. Okay, well, very similar to the last one. Starting on the positive x-axis, I rotate past 90 degrees, but not until 180. So I get an angle here of negative 150 degrees. And just for future reference in this lesson, I'm going to refer to these as the theta, which is a common variable used to represent angles. Okay, so those are angles in standard position. Now the next concept that's very important for cast is the concept of a reference angle. Now the reference angle, which I will usually denote by alpha, but you can denote it by any variable you like, is an angle that complements an angle in standard position. And what it is it's the angle that is the smallest angle between the terminal side of your angle and the x-axis. So in in red, I'm going to mark down the reference angles that correspond to all the angles given in question 1. So 1A, we have an angle of 135 degrees. Now what is the angle, the smallest angle between this terminal arm and the x-axis? Well, we can see it's this angle right here. So what is that? Well, that's 180 minus 135 is 45 degrees. Reference angles are always positive. We don't think about direction for the reference angle. It's just the angle between the x-axis and the terminal side. So I'm going to call that alpha. We see in B, what will be the reference angle? Well, the reference angle would be this angle right here. And that's the angle between 300 degrees and 360. So it is 60 degrees. In C, the reference angle, be careful, it's not this angle, it's not that angle. It's the smallest angle between the terminal side and the x-axis. So it would actually be this angle. Now what is that? Well, we rotated 60 degrees past 180. So here it would be 60 degrees. Finally, the reference angle for D, we can see the smallest angle between the terminal side and the x-axis is right here in red. And that is an angle of 30 degrees because we're 30 degrees shy of going the full 180 degrees. So that is sketching reference angles. The next concept that's important to know in terms of angles and standard position is something called a coterminal angle. Now, two angles are said to be coterminal if they share the same terminal arm. Co kind of means share. Now, essentially, this means the angles differ by a multiple of 360 degrees. So, for instance, name two coterminal angles. Okay, well, I can start with any angle I like. Let me start with, I don't know, 30 degrees. Now, any angle that differs by 360 from 30 degrees, plus or minus, is coterminal with it. So I can add 360 degrees to get 390 degrees. And I can say, okay, 30 and 390 are coterminal. Now, what does that mean? Well, if we draw 30 degrees in standard position, it will look something like this. And then if we draw 390 degrees in standard position, well, it will actually look the same. Well, the terminal arm will land in the same position on the plane, and their pictures will be identical. Okay, so that's 390 degrees. So coterminal angles are angles whose picture looks the same. I could have gone rotated in the other direction and got negative 330 degrees. And so there are infinite coterminal angles to any angle. You just keep adding 360, 720, and so on. Okay, so question 4. Find one negative angle and one positive angle that is coterminal with 120 degrees. So starting from 120, I can add 360 degrees to get 480 degrees. So that is coterminal with 120. Likewise, I can subtract 360 degrees to get negative 240 degrees, which is also coterminal with 120 degrees. The three angles, 120 degrees, 480 degrees, and negative 240 degrees, would all look like this if I drew them in standard. Okay, now our real motivation for learning all this is to easily be able to define and calculate trig ratios for obtuse angles. So, for example, let's consider the angle 135 degrees. Okay, well, I don't know a whole lot about 135 degrees when it comes to trig, but I know a lot about its reference angle, which is 45 degrees, the angle between the terminal side and the x-axis. So let's kind of zoom in on this little bit here. We have a 45 degree angle between the x-axis and the terminal arm, and let's make this into a right triangle. Okay, well, 45 degrees, you may remember its side lengths are 1, 1, root 2. And we, of course, we know from this triangle that the sine of 45 is 1 over root 2. The cosine of 45 is 1 over root 2. And the tangent of 45 degrees is 1. Okay. Now, that's true, sine 45, cos 45, and tan 45. But we want to know what is the sine, cos, and tan of 135 degrees. Well, if we think about it, we define the sine, cos, and tan of 135 degrees to be equal to the sine, cos, and tan of its reference angle, in this case 45 degrees, with some changes to the positive or negative sign in front of that value. So we notice here that if we look at this triangle, the adjacent side is negative because we're in quadrant 2. But the opposite side is positive. Okay, and of course the hypotenuse we define always to be positive. Okay, so sine is opposite over hypotenuse. So the opposite is positive and the hypotenuse is positive. So this is the positive sine of 45 degrees, which is 1 over root 2. The cosine of 135, remember, is this adjacent over hypotenuse. The adjacent is negative. The adjacent is negative when the hypotenuse is positive. So we're going to find this to be the negative cosine of 45 degrees. Let me write that a bit nicer. The negative cosine of 45 degrees, which is negative 1 over root 2. And now, okay, tangent is opposite over adjacent. Opposite is positive. Adjacent is negative. So again, this is going to be the negative tan of 45 degrees, which is negative 1. So this same pattern, like this triangle that we've drawn, will have the same positive, negative sides for any other angle in standard position that falls in quadrant 2. So in quadrant 2, sine will always be positive, cosine will always be negative, and tan will always be negative. So in general, any angle, it's the plus or minus of its trig ratios will depend totally on the quadrant that it falls in. So in quadrant 1, if we drew a triangle in quadrant 1, well, this side's positive, this side is positive, and the hypotenuse is always positive. So in quadrant 1, sine, cosine, and tan are all positive. Okay. In quadrant 2, okay, let's look in quadrant 2. Quadrant 2, well, this is the one we just did. So remember, we have a positive side and a negative side. So here, sine is positive, whereas cos and tan are negative. Okay. What about quadrant 3? Quadrant 3, we have two negative sides, negative and negative. What does that mean? Well, that means sine is going to be negative, cosine is going to be negative, and tan, which is a negative over a negative, will be positive. Okay. Last quadrant, quadrant 4, we have a positive side for the adjacent, a negative side for the opposite, and of course our hypotenuse is still positive. So here, well, what does that mean? That means the sine will be negative, the cosine will be positive, and the tangent will be negative. So we have a convenient acronym to remember these, which angles are positive in which quadrant. So let's look at each quadrant, 1 through 4. So in quadrant 4, remember what's positive there? Cosine. Cosine is positive, and only cosine is positive. In quadrant 1, all ratios are positive. In quadrant 2, the sine is positive. And in quadrant 3, the tan is positive. And so you can remember this by going C-A-S-T, which spells cast, but that C starts in quadrant 4, which some people confuse and put C in quadrant 1. So that is the cast drill. Now we can use this to now find trig ratios in other quadrants. And so let's look at some examples that are at the end of your handout. So let's find the exact value of cosine 225. Well, okay, where does 225 fall? That falls in quadrant 3. It's 45 degrees past 180. So although it is a rotation of 225 degrees, its reference angle is 45 degrees. So the cosine of 225 degrees is equal to the cosine of 45 degrees, except it may have a negative sign in front of it. And we can determine that from cast. So we're dealing with cosine in quadrant 3, where only tangent is positive. So this has to be negative. Negative 1 over the square root of 2. Okay, well now let's look at the next question. Calculate the trig ratios of the angle in standard position whose terminal arm lies on the point 6, -2. Okay, what does that mean? So we have an angle and its terminal arm lies on the point over 6 down 2. This is 6, -2. So its terminal arm is here. And we rotate all this way. Okay, well, I'm kind of confused. I don't know what the angle is. Let's see. Let's draw our little triangle. We have our reference angle alpha, whatever that is. This is the point 6, -2. That means this length of this triangle is 2. The length of this side is 6. And well, this is 36 plus root 36 plus 4, which is root 40. Okay, so the sine of, let's call the full angle theta. The sine of theta is the same as the sine of alpha, except it might have will it have a plus or a minus sign in front of it? Well, we're dealing with sine in the C quadrant, so yes, it will have a negative sign, so it's negative opposite over hypotenuse, so negative 2 over root 40. The cosine of theta is a positive. In this quadrant, cosine is positive. Cosine of alpha, which is 6 over root 40. And the tan of theta, here tan is negative in quadrant 4, which is -2 over 6. So note that we don't need to know what the angle is. It doesn't matter. We're just looking at ratios for this question. So don't worry about using your calculator to calculate angles here. It's unimportant. So lastly, this question says, it's telling you the cos of 40 degrees is 0.766, and it wants you to calculate the cosine of 140. Okay, well 140 falls right here, 140 degrees, but its reference angle is 40 degrees. So the cosine of 140 is going to be the cosine of 40 degrees, but we are in quadrant 2 where cosine is negative. So we just put a negative sign in front of that cos 40. This is negative then 0.766. So that's this lesson. I know this video is a bit long, but you're able to do it without me. You may have questions on this when I see you next. That's totally fine. Do your best to follow along with the homework. So note that we've not done radians yet, so some of the homework questions you will not have to do. So only do the ones that have angles that are in degrees. Thanks.